The atmosphere is the planet's invisible ocean, a vast and delicate veil of gases that clings to Earth like a protective skin. It cannot be seen, yet it is always felt, in the wind against your face, in the breath that fills your lungs, in the clouds drifting across the sky. It is both boundary and bridge, separating us from the vacuum of space while connecting every living creature through the air we share. Without it, Earth would be a silent, frozen rock, scorched by the sun by day and buried in darkness by night. With it, the world becomes alive, rivers flow, forests rise, storms gather, and voices carry. The atmosphere is not just air but a living system, constantly shifting, constantly shaping the rhythms of climate and weather, carrying within it the story of the planet's past and the possibilities of its future. To speak of the atmosphere is to speak of life itself, for every breath is a reminder of its presence and its gift. If you could peel away Earth's atmosphere, lifting it like a transparent cloak and setting it aside, the planet beneath would not be the world you know. Oceans might still glisten, continents might still sprawl, mountains might still cast shadows, but life, the kind of life that breathes, that grows, that walks and flies and sings, would not survive. The atmosphere is not just a blanket of gases surrounding a ball of rock and water. It is the essence of Earth as a living world, a membrane between ground and cosmos, a stage upon which weather dances, a shield against fire from above, and a reservoir from which life endlessly draws. To imagine Earth without it is to imagine a silence so total, a stillness so absolute, that the idea of a blue planet becomes only a memory. The atmosphere begins at the ground, though we rarely notice it. Each breath you take is atmosphere, each word you speak is carried by it, each raindrop that falls is born from it. You move through it as fish move through water, unaware of the medium because it is constant, surrounding, invisible. It presses on you with a weight of more than 10 tons, yet you do not collapse beneath it, because you are built within it, balanced against it, evolved to live under its pressure. The very act of being alive is possible because the atmosphere is here, pressing, supporting, filling. Its importance begins with breath. Oxygen, a fraction of the atmosphere but the most precious fraction, feeds the fire inside cells, allowing energy to flow through muscles and minds. Every animal that breathes, every insect that flutters, every fish that gulps air at the surface, relies on it. Plants in turn draw carbon dioxide, equally precious though toxic to us, using sunlight to turn it into sugars, into life. The atmosphere is the medium of exchange between green and flesh, between plant and animal, balancing one against the other. Without it, oxygen would vanish into space, carbon would lock itself in stone, and the cycle would break. The atmosphere is the contract of life, signed in invisible ink, renewed every moment as countless organisms inhale and exhale. But breath is only the beginning. The atmosphere is also the world's blanket, holding warmth against the chill of space. Without it, Earth would swing between extremes of heat and cold, like the moon, scorched in sunlight, frozen in shadow. Air moderates, distributing heat from equator to pole, softening the edges of day and night, storing warmth in water vapor and clouds, in the greenhouse gases that trap infrared radiation. Too much of those gases, and the blanket grows suffocating, smothering with heat, as on Venus. Too little, and the planet freezes, as on Mars. But Earth has found a balance, fragile and shifting, that allows rivers to flow, seasons to turn, and life to flourish. The atmosphere is thermostat and hearth, invisible fire and quiet cool, a regulator of habitability. It is also a shield. From above, the sun pours not only light but also fury, ultraviolet radiation, X-rays, cosmic rays, streams of charged particles. The atmosphere absorbs, scatters, deflects. Ozone in the stratosphere drinks the ultraviolet, sparing DNA from destruction. At higher altitudes, the thermosphere swallows X-rays, softening them into heat. Even meteors, those daily visitors from space, meet their end in atmospheric friction, flaring into harmless light before they can strike the ground. The atmosphere is Earth's armor, thin yet impenetrable, battered constantly yet enduring, making the difference between a sterile rock and a biosphere. Without it, the sun's brilliance would be lethal, and the universe's debris would pummel the surface unchecked. The atmosphere shapes the face of the world. Winds carve dunes, carry seeds, sculpt clouds. Rains erode mountains, feed rivers, nurture soil. Storms rage and subside, hurricanes churn, lightning cracks, snows blanket fields, all part of a cycle that redistributes water and energy across the globe. The circulation of air is the heartbeat of climate, moving warmth poleward, cold equatorward, mixing and balancing. Without atmosphere, there would be no weather, no rivers, no fertile soil, no seas replenished by rain. The earth would be static, unchanging, lifeless stone. With atmosphere, it is restless, ever-shifting, alive. Even the color of the sky is a gift of atmosphere. Molecules scatter blue light more than red, painting the dome above in azure by day, while at dawn and dusk, the low sun turns it gold and crimson. Without atmosphere, the sky would be black always, the sun a harsh, unblinking star, the stars visible even at noon. The beauty of sunsets, the gentleness of twilight, the soft veil of clouds catching fire at evening, all are creations of air. The atmosphere does not only sustain, it gives wonder, it gives poetry, it gives a world worth loving. Life itself sculpted the atmosphere, and the atmosphere in turn sculpted life. Billions of years ago, Earth's air was different, thick with carbon dioxide, with almost no oxygen, a veil of gases born from volcanoes. Then life arose in the seas, tiny cells learning to capture sunlight, to split water, to release oxygen as waste. Slowly, the waste became treasure, transforming the air, creating a sky rich in O2, allowing new kinds of life to evolve, complex creatures to breathe, animals to run and fly. The atmosphere is not static, it is a living record of life's presence. It remembers in its composition the history of oceans and forests, of volcanoes and ice ages, of extinctions and blooms. It is history written not in stone but in air. The importance of the atmosphere stretches even to the human imagination. It carries sound, the medium of voices and music, the waves of language, the cries of newborns, the laughter of gatherings, the hush of wind through trees. Without atmosphere, sound cannot travel, silence would reign, absolute and eternal. Imagine life without song, without speech, without the rustle of leaves, without thunder rolling or waves crashing. The atmosphere does not only sustain bodies, it sustains culture, connection, meaning. It is the breath of not just lungs but of stories. The atmosphere is also a communicator with the cosmos. It glows with auroras when touched by solar wind, signaling Earth's presence to space. It reflects and bends radio waves, creating invisible highways for communication long before satellites. It even leaks a faint halo of hydrogen, the geocorona, marking Earth with a signature visible to instruments far away. In this way, the atmosphere announces us, advertises us, makes us more than a silent stone adrift. To imagine Earth from afar is to imagine not just oceans and continents but also its shroud of air, glowing faintly, protecting fiercely. Consider water, the lifeblood of Earth. Without atmosphere, water would not stay liquid, it would boil away into space or freeze instantly in vacuum. The cycle of evaporation and rain, of clouds and rivers, is possible only because the atmosphere holds pressure and temperature within a narrow band. The oceans exist not just because water fell here long ago, but because the atmosphere holds them in place. Without air, seas would vanish into vapor, snowcaps would sublimate, deserts would expand endlessly. It is atmosphere that cradles the water cycle, and with it, all life. Yet for all its gifts, the atmosphere is delicate. A fraction of its balance shifted, and ice ages swept across continents. A fraction more, and warming threatens seas, forests, cities. We live in partnership with it, influencing it as much as it influences us. Industrial smoke, greenhouse gases, chemicals, our actions ripple upward, altering the balance of heat, of ozone, of rainfall. The atmosphere is not only protector but also mirror, reflecting back what we pour into it. To understand its importance is to understand responsibility, for in damaging it, we damage the very system that allows us to exist. Its scale is humbling. If Earth were the size of an apple, the atmosphere would be its skin, thin, fragile, easily disturbed. And yet within the skin unfolds the totality of life. Within it fly the birds, carry the clouds, form the storms. Within it soar airplanes and balloons, satellites skim at its edge, rockets tear through it. Its thinness belies its power. Without this skin, Earth would be lifeless. With it, Earth is abundant. The atmosphere even shapes time. Its circulation drives weather, and weather drives harvests, migrations, the rhythm of seasons. Festivals, calendars, mythologies, all are tied to the cycle of air and sun. Lightning sparked ancient fires, rains nourished early agriculture, winds carried ships across oceans, opening continents to one another. History itself has been carved by atmosphere, droughts that toppled civilizations, storms that sank armadas, fertile valleys that gave birth to empires. Air is not backdrop, it is actor, shaping destinies. Perhaps its greatest importance lies not in any one role but in its wholeness. It is the binding fabric of earth, connecting sea to land, life to stone, present to past. It is the unseen ocean in which we swim, the unseen hand that steadies climate, the unseen shield that holds death at bay. We forget it because it is always there, but to lose it, even in imagination, is to feel the void open. Mars is barren without it. The moon is silent without it. Venus is poisoned by too much of it. Only Earth holds the delicate balance, and that balance is atmosphere. When you stand outside on a windy day and feel the rush of air against your face, you are not simply feeling weather. You are feeling the touch of the system that makes your existence possible. When you watch a cloud drift across the sky, you are watching the machinery of climate and life. When you breathe deeply, filling your lungs, you are partaking in a cycle older than humanity, older than animals, a cycle that began when the first tiny cells learned to transform light. To live is to be in constant exchange with the atmosphere, to share yourself with it, to draw from it and give back to it. Earth's atmosphere is important not just as a scientific fact but as a truth of belonging. It ties us to this planet, defines us as terrestrial, binds us to the great cycles of water, carbon, oxygen, and nitrogen. It makes Earth not just habitable but beautiful, not just survivable but rich. Without it, Earth would be stone. With it, Earth is home. And so, when you look up at the sky, remember, you are not looking into emptiness. You are looking into the very thing that sustains you, protects you, connects you to every living being. You are looking into the atmosphere, the invisible cathedral beneath which all life has sung its song. To know its importance is to know gratitude, awe, and humility. For it is not just the air we breathe. It is the breath of Earth itself. The atmosphere, that invisible ocean of gases that embraces our world, is often taken for granted, as if it were simply empty space or nothing more than the air we breathe. Yet the truth is that it is a delicate, layered, and intricately balanced symphony of molecules, each one participating in a story that has been unfolding since Earth was young. To wander through its composition is to wander through a great narrative of chemistry, physics, and life itself. Imagine peeling back the veil of invisibility and seeing not a blank transparency, but a living mosaic, an ever-shifting quilt of gases that dance around each other, weaving the conditions for rivers, mountains, forests, oceans, and human dreams to exist. If one were to scoop a handful of air in a clear, invisible jar, it would not look like much. But hidden within that jar is a portrait of the planet. The largest brushstroke in this portrait belongs to nitrogen, the quiet giant of the atmosphere, making up nearly 4/5 of the whole. Nitrogen does not boast like oxygen does, nor does it sparkle with drama like carbon dioxide. It is instead the calm background, the steadying presence, inert and reliable, giving the atmosphere its bulk and stability. Though nitrogen seems inactive, it is the sleeping giant upon which life depends. Its molecules drift in pairs, tightly bonded, almost impossible to break apart. And yet in the soil, in the roots of plants, in flashes of lightning, these molecules are pulled apart and rearranged, becoming food for life. Without nitrogen, there would be no proteins, no DNA, no muscle or skin or thought. The air would still exist, but it would be hollow, unable to nourish the chemistry of growth. Alongside nitrogen, like a companion always ready to intervene, comes oxygen, making up 1/5 of the air we breathe. Oxygen is the fire of life, the element that makes our cells hum with energy, the invisible fuel that turns food into warmth, motion, and memory. Unlike nitrogen, oxygen is eager, restless, quick to combine, quick to burn. Where nitrogen waits, oxygen leaps. It feeds the flames of campfires, the rust of iron, the metabolism of animals. It is the reason we inhale deeply when we run, the reason a forest is alive with breathing, unseen currents of respiration weaving through the trees. Oxygen is also a shaper of the planet's geology. Long before we walked here, oxygen began oxidizing rocks, changing the face of mountains, altering the chemistry of oceans. It was not always abundant. Once, billions of years ago, Earth's atmosphere was poor in oxygen, and it took the patient work of cyanobacteria and plants to exhale enough of it into the sky for animals like us to be possible. Every breath you take, whether on a busy city street or in the silence of a desert night, is a continuation of that ancient revolution. But not all presences in the atmosphere are so abundant. Argon, for instance, is the quiet loner, content with less than a single % of the mix, yet steady and enduring. Argon does not bond, does not interfere, does not participate in the fiery exchanges of oxygen or the cycles of nitrogen. It is noble, in the truest chemical sense, one of the noble gases, drifting untouched and untouched by others. Its role might seem unimportant compared to the drama of oxygen or the essential foundation of nitrogen, yet argon is like a subtle pause in a symphony, the silent intervals that give structure to music. It is a reminder that not all things in nature exist to be consumed or transformed. Some simply persist, giving the atmosphere stability, a kind of neutrality that allows the more reactive gases to play out their roles. Argon is also a time capsule, carrying the memory of Earth's formation. It is a remnant, a whisper from the beginning, still hovering above us billions of years later. And then, there is carbon dioxide, the gas that has become a household name, both feared and misunderstood. In truth, carbon dioxide is tiny in measure, barely a fraction of a % of the atmosphere. Yet its power is disproportionate to its presence. Without it, Earth would be a frozen wasteland, a barren marble too cold to cradle seas or forests. Carbon dioxide is the keeper of warmth, the invisible blanket that holds the sun's heat close to the surface, letting life flourish. But it is also a storyteller of cycles, released from volcanoes, inhaled by plants, exhaled by animals, dissolved in oceans, trapped in rocks, freed again after millions of years. Each molecule of carbon dioxide drifts in an endless journey, sometimes in the lungs of a child, sometimes in the leaves of a tree, sometimes buried in ice deep at the poles. Its influence is delicate, too little, and the planet freezes, too much, and the balance tips toward heat and disruption. Humanity has learned this the hard way, watching as our own activities, our burning of ancient carbon in coal and oil and gas, have thickened the blanket and shifted the climate. Carbon dioxide reminds us that even the smallest brushstrokes in the atmosphere's portrait can change the entire canvas. Beyond these familiar names are others less often spoken of, yet vital in their own ways. Neon, helium, krypton, xenon, trace gases, making up slivers of percentages, but each carrying its own peculiar role. Neon glows in signs, but in the atmosphere it simply drifts, inert and unconcerned. Helium, so light it often escapes to space, is a reminder that the atmosphere is not sealed but a leaky boundary between Earth and the cosmos. Krypton and xenon, mysterious and heavy, are like hidden gems, appearing in such tiny amounts that they are almost like footnotes in the atmosphere's story. Yet even these traces tell us about the origins of the planet, about radioactive decay in the crust, about cosmic influences that seeded Earth long ago. And then there is ozone, not abundant enough to be counted among the primary components, yet crucial beyond measure. Ozone is a cousin of oxygen, 3 atoms bound together instead of 2, fragile and rare, yet powerful in its ability to absorb ultraviolet radiation. Without ozone, the sun's rays would scorch the surface, sterilizing land, making life precarious. Ozone hangs mostly in the stratosphere, forming a thin shield, invisible to the eye yet protective enough to allow jungles, grasslands, and coral reefs to thrive. Like carbon dioxide, it shows us that importance is not measured by abundance. Water vapor is another ghostly participant, its amount changing by the hour, by the season, by the geography of mountains and seas. At times it may be just a trace, at other times it swells to several percent of the air, carrying heat, forming clouds, driving storms. Water vapor is the breath of the atmosphere, its moods and tempers written in vapor trails and mists, in humid afternoons and parched deserts. Unlike nitrogen and oxygen, which remain steady, water vapor is always in motion, condensing, evaporating, freezing, raining. It is the atmosphere's most dynamic player, shaping weather and climate, making the difference between fertile plains and barren wastelands. Each of these gases does not live in isolation. They interact in invisible, intricate dances. The nitrogen provides the stage, the oxygen adds the fire, the carbon dioxide tempers the warmth, the argon gives balance, the trace gases add nuance, and the water vapor ensures constant change. Together, they are not just air but the conditions for oceans to flow, for forests to stretch skyward, for civilizations to rise. To breathe is to take part in this grand composition. When you inhale, nitrogen fills your lungs, silent and steady. Oxygen rushes into your blood, igniting the chemistry of life. Carbon dioxide leaves your body, returning to the sky to begin another cycle. Argon drifts in and out, untouched, a quiet witness. And perhaps, in that same breath, a molecule of water vapor enters, ready to condense into a raindrop, or a stray trace of neon passes through, unchanged since the planet's earliest days. Every breath is a participation in the story of Earth's atmosphere, a reminder that we are not separate from it but immersed within it, woven into its chemistry. The atmosphere's composition is not static, it changes, subtly with the turning of seasons, dramatically with the influence of life and human activity. Plants exhale oxygen in daylight. And in great forests, the balance between oxygen and carbon dioxide shifts with the rising and setting sun. Volcanoes release bursts of gases that alter the mix, sometimes for years at a time. Human factories, vehicles, and power plants burn fuels, releasing carbon dioxide, methane, and nitrous oxide, bending the proportions just enough to change climate patterns across the globe. The air is never still, never frozen, it is alive, fluid, and responsive. To understand its composition is to understand both its fragility and its strength. Fragility, because even small changes in the trace gases can alter the climate, the shield of ozone, the weather patterns upon which civilizations depend. Strength, because despite all this, the atmosphere has persisted for billions of years, cycling through ice ages and warm periods, volcanic winters and green revolutions, always adapting, always holding Earth within its protective embrace. The atmosphere is not just chemistry. It is memory. Within its gases are records of ancient times, trapped in bubbles and glaciers, whispering to scientists about climates long past. Within its composition are signatures of life, the fingerprints of plants and animals and humans. The nitrogen tells of cycles through soil and roots. The oxygen speaks of forests and algae. The carbon dioxide speaks of oceans and volcanoes, of industry and machines. The argon and neon speak of the planet's deep time, of origins before any life stirred. To know the atmosphere's composition is to read a story billions of years in the making, a story not finished but still unfolding, with us as characters within it. It is both a stage and a participant, both a backdrop and a voice. And when we lift our heads to the sky, we are not looking at emptiness. We are looking into the delicate balance of gases that make our world what it is. The air that wraps itself around the Earth, the breath of our planet, begins low, so low that it clings to mountains and valleys, forests and seas, and it carries the scent of pine and salt and dust, mingling them into a perfume only this world knows. This lowest realm of air, this intimate space where life rises and breathes, where wings beat and rains fall, is called the troposphere. It is not merely a layer of atmosphere, it is the great theater where weather plays out, where clouds form and dissolve, where storms are born with a whisper and rage with thunder, where the planet's moods are painted across the sky in shifting light and color. You live inside this theater, though most days you forget it is there, until the wind tears at your coat or the summer heat presses on your skin or the snow muffles sound as it falls. The troposphere is not distant, it is your constant companion. It begins at the surface of the Earth and stretches upward, a veil whose thickness changes with latitude and season. Near the equator it swells high, like a great dome rising 15 kilometers into the sky, swollen with heat and energy. Near the poles it droops, thinner, sometimes only 8 kilometers deep, compressed by cold. Yet whether thick or thin, it holds nearly all the air you breathe and nearly all the weather you know. Above it, higher layers of atmosphere stand more aloof, thinner, stranger, less concerned with your daily life. But here, in the troposphere, life and weather are intertwined, and the restless heart of the sky beats loudly. If you could rise gently upward, lifted on some impossible thread, you would feel the world changing around you. At sea level, the air presses on you with its full weight, thick and rich with oxygen and moisture. It is warm, carrying the fragrance of Earth. As you ascend, the pressure weakens, the air thins, your lungs strain for breath. The temperature falls, about 6.5 degrees Celsius for every kilometer you climb. This steady decline is the lapse rate, the slope of cold that defines the troposphere. Higher and higher you go, and the air cannot hold as much water vapor, so clouds begin to form, sometimes thin and wispy, sometimes towering and powerful. At the top, at the tropopause, the fall of temperature halts, and a lid is set upon the chaos of weather below. There, the restless vertical motions of air are capped, storms cannot grow beyond it, and the upper layers of atmosphere begin, calm in their own way. But below that ceiling lies turbulence, invention, beauty, and fury. The troposphere is restless because the Earth is unevenly heated. The equator, under the direct gaze of the sun, swells with heat, while the poles, tilted away and cloaked in snow, cool and contract. The surface itself is patchy. Oceans absorb and release heat differently than land, deserts differ from forests, mountains lift the air, valleys cradle it. Warm air rises, cool air sinks, and the entire layer churns with these motions, like water in a pot set upon a stove. The churning does not end, because the heat never stops flowing from sun to earth, from equator to pole, from surface to sky. And so, in this restless motion, weather is born. Look up on a summer afternoon. You may see white puffs drifting lazily across blue, cotton piled against infinity. They are cumulus clouds, born of rising thermals. The ground is heated unevenly, perhaps a plowed field or a dark rooftop grows warmer than the meadow beside it. The air above that warm patch rises, carrying moisture. As it lifts, it cools, and the water vapor condenses into droplets that scatter sunlight and appear as cloud. At first small, the cloud may grow, fed by more rising air, until it becomes a mountain of vapor, brilliant in sunlight, casting shadow below. Some cumulus remain playful, their tops dissolving as fast as they grow, fair weather friends. But some climb higher, nourished by stronger updrafts, pushing toward the tropopause, flattening at its ceiling until they spread wide as anvils. Then you have a cumulonimbus, a storm cloud, a cathedral of water and energy. Inside, droplets collide, grow, freeze, fall, and rise again. Lightning crackles. Thunder rolls, rain lashes the ground, and hailstones may form, layered like jewels of ice. The storm cloud is alive, a breathing, rumbling entity, and it is a child of the troposphere. The troposphere's clouds are as varied as moods. High above, near the ceiling, cirrus clouds spread thin and feathery, streaks of ice crystals drawn by winds. They glow pink in dawn and dusk, messengers of change, for their presence often heralds a shift in weather. Lower down, stratus clouds lie gray and heavy, draping the sky in a sheet, muting the world with dim light. Between, you may find altocumulus, rolling like sheep across the firmament, or nimbostratus, bringing steady, soaking rain. Each cloud type is not just a shape but a story of temperature, humidity, and motion. The troposphere writes its tales in these patterns, and humans have long read them, predicting rain, storm, or fair skies by their forms. The weather here is sculpted not only by rising warmth but by the turning of the earth. The planet spins, and the air cannot move freely from equator to pole, it is deflected, twisted into great streams. The trade winds, the westerlies, the jet streams, all are born of this dance between rotation and temperature. The jet stream, that narrow ribbon of furious wind at the tropopause, races along at hundreds of kilometers per hour, steering storms, carrying them across continents. Beneath it, cyclones and anticyclones spin, drawing moist air upward, pressing dry air downward, shaping the forecasts that govern crops and journeys, celebrations and disasters. Imagine standing at a coastline when a storm approaches. Far out to sea, the troposphere has been brewing a disturbance. Warm water has given up heat to the air, fueling it with energy. The system begins as clusters of thunderstorms, but the Coriolis effect twists them, and they organize into a spiral. If conditions are right, if the sea is warm enough and the winds aloft are gentle, the storm grows, a tropical cyclone is born. It feeds on the ocean's warmth, its calm while its walls roar with rain and wind. Such storms, called hurricanes or typhoons depending on their home, are the troposphere at its most terrifying, yet also its most magnificent. They are heat engines, transporting energy from ocean to atmosphere, balancing the planet's books of temperature. They devastate human lives, yes, but they are also part of the great system that keeps Earth habitable. Storms need not be so vast to command awe. Over the Great Plains of North America, the troposphere sometimes stages its own grand drama. There, warm moist air from the Gulf of Mexico meets cold dry air from Canada, and the collision breeds instability. Towering supercells rise, their updraft spinning, sculpted by wind shear into tilting monsters. Within them, the atmosphere twists further, and funnels may drop, tornadoes, whirling columns of air that scour the ground with violence. To see one from a safe distance is to glimpse the raw power of the troposphere, a narrow fury birthed from the meeting of winds. Lightning dances within these storms, discharging the tensions of cloud and ground, illuminating the night in stark brilliance. Thunder follows, the voice of air shaken by sudden heat, rolling over hills and plains. Rain lashes, hail pounds, and then, sometimes, silence falls, the storm spent, the sky cleansed. Yet the troposphere is not only violent, it is also tender. Consider the morning mist that hovers above a meadow. The ground cooled overnight, chilling the air just enough to condense water vapor into droplets that hang suspended, scattering light into softness. Or the gentle fall of snow, each flake a tiny crystal grown from vapor in the cold upper air, each unique, drifting down to cover the world in silence. Even the subtle shift of light at sunset, the scattering of shorter wavelengths leaving the reds and oranges to paint the horizon, is a gift of the troposphere. Without it, the sky would be black and empty, and the sun a blinding disk. With it, the sky is alive, a canvas of change. The troposphere's weather is not isolated events but a continuous cycle, a restless seeking of balance. Heat absorbed at the equator must be moved poleward. Water evaporated from oceans must return as rain. Winds carry dust from deserts across oceans to fertilize forests. Rains carve rivers, rivers feed seas, seas give vapor back to air. The troposphere is not separate from the biosphere or the hydrosphere, it is entwined with them. Life depends on it utterly. Without the troposphere's greenhouse gases, the Earth would be a frozen rock. Without its storms, heat would stagnate. Without its rains, deserts would spread. To live on Earth is to live within this layer, to breathe its breath, to feel its moods. For as long as humans have looked upward, they have read the troposphere's signs. Farmers watch the sky to know when to plant and harvest. Sailors read the winds and clouds to steer their ships. Poets and painters found in the shifting skies metaphors for love, loss, hope, and despair. Even now, with satellites orbiting above and supercomputers calculating the future of storms, we still look up, still feel small beneath the towering clouds, still thrilled or frightened by the crack of thunder. Technology may extend our vision, but the troposphere remains a living presence we cannot ignore. And it is changing. Human actions, though grounded on the surface, ripple upward. Greenhouse gases accumulate, thickening the blanket of air, altering the balance of heat. The troposphere warms, its patterns shift. Storms may grow stronger, rains heavier, droughts longer. The jet streams wander, the polar air escapes southward. What once seemed eternal is revealed as delicate. The troposphere, though vast, is not invulnerable. It carries the mark of our civilization, and it will answer in weather, in clouds, in storms. Yet to despair would be to miss the beauty still present. Step outside on a spring morning when the air smells of blossoms and damp soil. Watch the clouds drift, reshaping themselves as if they are alive. Feel the breeze, gentle or brisk, carrying with it the memory of distant places, the sea, the desert, the forest. The troposphere touches everywhere, linking every landscape, every life. In its motions is written the interconnectedness of Earth. You are part of it, not apart from it. If you could listen deeply, you might hear the troposphere breathing. In the sigh of wind through trees, in the whisper of falling snow, in the crash of surf driven by distant storms. If you could see it whole, from space, you would behold swirling white patterns, cyclones and fronts, bands of cloud girdling the globe. It would look fragile, a thin film clinging to a blue sphere. Yet within that film lies everything we call weather, every raindrop and snowflake, every gust and calm, every bolt of lightning. It is fragile and powerful, tender and fierce, chaotic and orderly. It is the troposphere, the living sky of Earth. To understand it is to understand the dance of heat and moisture, the ceaseless attempt of the planet to balance itself. To feel it is to stand in the rain, to watch clouds pile into towers, to shiver at the approach of a storm. To live within it is to be constantly reminded of change, for no 2 days are alike. The troposphere teaches impermanence, unpredictability, resilience. It teaches awe. And so, when you next look upward, do not think of the sky as empty. Think of it as full of motion, of water and heat, of invisible currents and towering clouds. Think of it as a companion, shaping your days and nights, whispering through winds, painting sunsets, thundering in storms. It is the troposphere, and it is alive around you, always, the great stage on which Earth performs its weather, the breath in which life unfolds. Above the restless, ever-changing weather, beyond the tumbling storms and drifting clouds of the troposphere, lies a quieter realm. It does not announce itself with thunder or pour its presence upon the ground as rain. It does not churn with the same wild unpredictability of the air beneath. Instead, it stretches outward in calm expanses, a strange kingdom of clarity and order, where the rules of the atmosphere seem to shift, and the mood of the sky changes. This is the stratosphere, the second layer of Earth's atmosphere, an invisible arch that begins above our heads at the ceiling of storms and reaches to altitudes where the air is almost too thin to imagine. Though it feels distant and detached from daily life, the stratosphere is woven into the fate of the world, holding secrets that have shaped life and will continue to shape it as long as our planet endures. If you could rise upward from the ground, leaving behind the familiar sensations of warmth, wind, and clouds, you would first pass through the troposphere. You would feel the air growing colder as you climbed, the chill biting with every 1,000 meters. The pressure would fall, your breath would thin, and the clouds would surround you before you pushed through them. Then, at somewhere between 8 and 15 kilometers above the surface, depending on where on Earth you stand, you would reach a strange boundary, a lid on the world's weather. It is here, at the tropopause, that the relentless cooling halts. The air stops becoming colder with height. Instead, paradoxically, it begins to warm as you go higher. This reversal, this odd temperature increase with altitude, is the signature of the stratosphere, the reason storms below cannot break into it. The troposphere is a cauldron of rising and sinking air, but the stratosphere is layered, stratified, its structure stable, resisting the mixing turbulence below. It is a quieter ocean of air, but within that calm lies power. Here the air is thin, dry, and mostly clear. There are no clouds in abundance, no raindrops forming in clusters, no familiar weather systems swirling in daily drama. The world below, with its forests and cities, oceans and mountains, shrinks into a curved horizon. Above, the sky deepens into a darker shade of blue, hinting at the blackness of space. To float here is to linger between Earth and cosmos, in a place that seems almost untouched by life. Yet the stratosphere is far from empty. It holds within it something invisible, something that has shaped the history of every living creature, the ozone layer. Ozone is only a trace gas, a fragile veil of molecules composed of 3 oxygen atoms each. But its role is monumental. It forms a band within the stratosphere, absorbing much of the sun's ultraviolet radiation, that fierce, invisible light that can damage DNA and strip life bare. Without this shield, life on land would have remained impossible, the surface seared by relentless rays. In deep time, billions of years ago, before the ozone layer existed, only the oceans provided enough protection for early life. As photosynthetic organisms began to release oxygen into the air, ozone formed naturally in the upper atmosphere. Slowly, it thickened into a layer strong enough to turn aside the most dangerous ultraviolet radiation. With this shield, life crawled from the seas, colonized the land, and built the teeming, diverse biosphere we now inherit. The stratosphere, though silent, gave life its chance. If you could see ozone at work, you would witness sunlight striking oxygen molecules high above, splitting them into single atoms, which then recombine into ozone. These molecules, fragile and short-lived, are constantly created and destroyed in a cycle that maintains balance. When ultraviolet photons hit them, the energy is absorbed, transformed into heat, and this absorption warms the stratosphere, creating the inversion that makes its structure unique. In this way, the ozone layer is both shield and architect, shaping the temperature profile of the atmosphere. Without it, the stratosphere would not exist as we know it, and the Earth would be an alien world. The calmness of the stratosphere can be deceptive. For it is a realm of grand circulations and slow but profound movements. Unlike the turbulent convection of the troposphere, here air flows in broad rivers and great overturning loops. Winds can stretch across thousands of kilometers, steady and strong, carrying aerosols from volcanic eruptions, smoke from wildfires, even dust from deserts. The stratosphere connects regions of Earth in ways unseen, transporting materials across hemispheres, linking the fate of far-flung places. The Brewer-Dobson circulation, a vast conveyor belt of air, rises in the tropics, flows poleward, and sinks at higher latitudes, distributing ozone and other gases. It is slow, almost stately, but it shapes the chemical composition of the sky, deciding where the shield is thickest or thinnest, where ultraviolet light can penetrate more deeply. From the ground, you rarely notice the stratosphere. Its existence is revealed only in glimpses, in phenomena that seem almost otherworldly. On winter nights in polar regions, strange luminous veils can appear, nacreous clouds, also called mother-of-pearl clouds, shimmering in iridescent colors. They are rare, formed only when the air is cold enough for ice crystals to condense in the stratosphere, far higher than ordinary clouds. Their beauty is haunting, but they carry a darker role. On their surfaces, chemical reactions can accelerate the destruction of ozone, contributing to the famous ozone holes that scar the polar stratosphere in spring. These holes are not empty voids but regions where ozone thins dangerously, where human-made chemicals, chlorofluorocarbons, or CFCs, have triggered chain reactions that break down ozone molecules faster than they can be replenished. The discovery of these holes in the late 20th century shocked humanity into realizing its power to alter even the highest layers of the sky. The global response, the Montreal Protocol, stands as one of the rare triumphs of collective action, phasing out many ozone-depleting substances. Slowly, the ozone layer is healing, though scars remain, a reminder that even the stratosphere, aloof and distant, is not beyond human touch. Though less dramatic than thunderstorms, the stratosphere holds its own forms of weather, subtler but profound. One of the most mysterious is the sudden stratospheric warming. In polar winters, high-altitude winds can shift and collapse, leading to a rapid rise in stratospheric temperature by tens of degrees. This disruption cascades downward, disturbing the troposphere below, altering jet streams, and even reshaping weather patterns for weeks. What begins high above the reach of ordinary perception can ripple downward to touch daily life, changing snowfalls, cold snaps, or rains. The stratosphere is not separate from the weather we know, it whispers into it, nudging the patterns we take for granted. Consider also the marks left by volcanic eruptions. When a volcano of great force explodes, it can blast ash, sulfur dioxide, and aerosols high enough to pierce the stratosphere. There, where rain does not wash them quickly away, they can linger for months or years, spreading across the globe. They form veils that scatter sunlight, cooling the surface below. The eruption of Mount Pinatubo in 1991 hurled millions of tons of material into the stratosphere, lowering global temperatures for nearly 2 years. Such events remind us that the stratosphere is a global commons, a space where disturbances in one place ripple across the entire world. The calmness of its blue silence hides a stage where the Earth's largest dramas can unfold. Within this layer, too, high-speed winds form streams and patterns, most famously the polar vortex. This vast cyclone of cold air spins above the poles in winter, contained by strong winds in the stratosphere. When stable, it locks the cold over the Arctic or Antarctic. But when disturbed, it can wobble, split, or weaken, sending frigid air spilling southward into continents, bringing deep freezes to places unaccustomed. The polar vortex is a stratospheric phenomenon with tropospheric consequences, a reminder of the invisible threads linking the quiet upper atmosphere with the turbulent lower one. In the stratosphere, the air is thin, too thin for ordinary planes to fly comfortably. Yet it is where some of the most remarkable feats of aviation and exploration have reached. High-altitude research balloons drift into it, carrying instruments that peer into its chemistry, its winds, its secrets. Military planes like the U-2 and State Route 71 once soared there, skating the edge of space, their pilots gazing into skies so dark they could see stars at noon. And for a brief time, commercial passengers tasted the stratosphere aboard supersonic Concorde jets, which cruised high enough to rise above weather, leaving contrails far above the clouds. To look from such altitudes is to see the curve of Earth, the thin blue arc of atmosphere, and to sense both the fragility and the grandeur of the air that holds life. The stratosphere's reach is not confined to Earth. It teaches us how atmospheres work, how planets protect or fail to protect their surfaces. Venus has no ozone layer, ultraviolet light batters its clouds unhindered. Mars, with its thin air, cannot hold such a shield. To study Earth's stratosphere is to glimpse what makes our planet unique, to understand why it fosters life so abundantly while its neighbors remain hostile. It is a mirror in which we see both our fortune and our responsibility. Though distant from daily life, the stratosphere plays a subtle role in human culture. The auroras, though primarily in the thermosphere above, are sometimes glimpsed cascading downward, their light filtering into the stratosphere. The legends of the sky, the sense of wonder at its heights, are enriched by the knowledge that unseen layers protect and shape us. Writers and dreamers have imagined rising into these heights, crossing thresholds where Earth ends and space begins. And indeed, the boundary between stratosphere and mesosphere above is the gateway through which spacecraft must pass, the realm into which rockets roar before breaking free. It is easy to think of the stratosphere as simply above, remote and irrelevant. But its chemistry, its winds, its shields are all entwined with the lives below. The ultraviolet rays it absorbs determine the rate at which plants grow, how plankton thrive, how animals and humans survive. Its circulations influence the rhythm of monsoons, the reach of droughts, the patterns of storminess. When humanity scarred it with chemicals, cancers rose, ecosystems strained. When volcanoes veil it with aerosols, crops may falter, climates cool. This quiet realm, so unlike the boisterous troposphere, exerts a hand that is firm yet unseen. And perhaps that is the wonder of the stratosphere, that it reminds us the world is layered, complex, and interconnected in ways beyond our senses. You cannot see ozone, yet it shields your skin every time you walk into sunlight. You cannot feel the polar vortex, yet its shifts may determine whether your winter is mild or severe. You cannot taste volcanic aerosols, yet they alter the light of sunsets, painting them in strange hues after great eruptions. The stratosphere is a reminder that the most vital forces are often invisible, working above and around us in silence. If you imagine standing at the edge of space, looking back at Earth, you would see the stratosphere as part of the fragile film that envelopes our planet. From that vantage, the air looks impossibly thin, a narrow line between blue oceans and black void. And yet, in that line lies the shield that made forests possible, the winds that tie hemispheres together, the chemistry that spared life from ultraviolet destruction. The stratosphere is both delicate and vast, vulnerable to human interference yet powerful enough to steer climates and carve the course of history. In the end, the stratosphere is not an alien world above but an essential part of home. It is where sunlight is tamed, where heat is redistributed, where the Earth negotiates its relationship with the cosmos. It does not boast with storms or daily spectacle, but its quiet is deceptive. It is a place of hidden labor, of slow rhythms, of protective grace. To know it is to deepen your awe for the sky, to realize that even in its silence, it holds life's fate in balance. The stratosphere is not only above you, it is part of you, woven into every breath, every step under the sun. It is the high, calm heart of the atmosphere, holding vigil over the restless world below. Above the calm and layered stratosphere, higher than the gentle shield of ozone and the thin highways of jet streams, lies a realm of cold, mystery, and beauty. Few humans have ever visited it, fewer still have lingered there, for it is too high for airplanes to fly and too low for satellites to orbit. It is a hidden kingdom, a middle place between the stratosphere below and the thermosphere above, and its name reflects that in-between nature, the mesosphere, the middle layer of Earth's atmosphere. Remote and silent, it is a place where fire streaks across the sky, where strange glowing clouds drift at the edge of space, where temperatures plummet to extremes that would freeze breath in an instant. It is not the realm of daily weather, nor the home of storms, but it is a place where the Earth meets the cosmos, where fragments of the universe burn away before they can touch the ground. To reach it, you must rise past the tropopause and its ceiling of storms, past the clear ozone-laden layers of the stratosphere, past the cruising heights of supersonic jets and the drifting balloons that carry instruments into the thin blue. At about 50 kilometers above the surface, the stratosphere's slow warming ends, and the temperature once again begins to fall with altitude. This reversal marks the beginning of the mesosphere, and as you ascend further, the cold deepens beyond anything familiar. By 85 kilometers, near its top, the air has thinned to near nothing, and temperatures have dropped to some of the lowest found anywhere on Earth, dipping far below -90 degrees Celsius. The mesosphere is the cold heart of the atmosphere, the freezer between layers, and its chill shapes the strange phenomena that dwell there. The mesosphere is not an easy place to visit. It lies above the reach of aircraft and below the stable orbits of spacecraft. Rockets can pass through it, and sounding rockets sometimes pause within it for moments, releasing instruments to taste its chemistry and winds. But no one has stayed there, no permanent human presence has ever been established in this middle layer. What we know of it comes from fleeting glimpses, from remote sensing, from the trails of meteors, from the shifting dance of its rare clouds. This remoteness gives the mesosphere an aura of mystery, as if it is a secret world that allows only brief intrusions. Perhaps its most dramatic display is meteors. Every day, countless fragments of cosmic dust and rock stream into Earth's atmosphere. They strike the air at immense speeds, tens of kilometers per second, faster than imagination. The mesosphere is where most of them meet their fiery end. As they slam into the thin air, friction and compression heat them, causing them to glow, to streak as bright lines across the night sky. Some are small, no larger than grains of sand, and they burn quickly, vanishing in a flash. Others carve longer trails, glowing in green or white, sometimes leaving glowing paths that linger for moments. To stand beneath a meteor shower is to witness the mesosphere at work, to see the shield it provides, consuming the celestial rain before it can harm the surface. Without the mesosphere, the Earth would be scarred daily by impacts. With it, the sky itself burns the debris, a sacrificial fire in the cold air, a reminder that we are protected by unseen layers. The mesosphere does not only consume, it also creates beauty of its own. In the summer twilight, near the poles, when the sun is just below the horizon and the sky is darkening, something remarkable may appear. Higher than ordinary clouds, delicate veils of pale blue light shimmer against the darkness. They are noctilucent clouds, the highest clouds on Earth, formed in the mesosphere at altitudes near 80 kilometers. Their name means night shining, and they are just that, clouds that glow after sunset, reflecting sunlight from beyond the horizon. They are made of ice crystals, formed on the dust of meteors, tiny seeds drifting in the rarefied air. Their faint shimmer is elusive, a silver glow that looks otherworldly, as if the sky itself were breathing light. They are recent in human memory, the first sightings were in the late 19th century. After a great volcanic eruption. Since then, they have become more common, perhaps linked to changes in the atmosphere, to increasing water vapor and cooling in the upper air caused by human activities. To see noctilucent clouds is to glimpse a sign of both beauty and fragility, a wonder that whispers of the atmosphere's sensitivity. Within the mesosphere, the air is too thin for lungs to use, too cold for life to survive, too remote for daily weather to intrude. Yet it is not empty. Winds sweep through it, sometimes with immense speed, part of the tides and waves that ripple upward from the lower atmosphere. These atmospheric tides are not tides of water but of air, great undulations driven by the heating of the sun, by the rise of mountains, by the flow of weather below. They climb into the mesosphere, growing larger as the air thins, until they can break like waves on a shore, releasing their energy. This breaking of waves is one of the mysteries of the mesosphere, a process that shapes the circulation of the entire atmosphere, coupling the layers together. The mesosphere, though remote, is not disconnected. It listens to the lower world, feels its turbulence, and responds with motions that ripple upward still further. This layer is also where strange flashes of light, elusive and rare, sometimes dart above storms. Though lightning belongs to the troposphere, it can trigger phenomena that leap into the mesosphere: red sprites, blue jets, elves. Sprites are enormous, branching flashes of crimson light, stretching upward like tendrils above thunderstorms, sometimes reaching into the mesosphere. Blue jets shoot upward from cloud tops, narrow and fast. Elves expand in glowing rings, spreading for hundreds of kilometers in a fraction of a second. These transient luminous events, as they are called, were once dismissed as myths, seen only by pilots or rare observers. Now they are known as real, and they reveal that the mesosphere is alive with electric responses to the drama below. It is a theater for light, silent and fleeting, a reminder that even in its thin, cold air, forces of great power are at play. The mesosphere is also the boundary of what can be called space. Above it, in the thermosphere, the air is so thin that satellites can orbit, held aloft by their speed. Below it, in the stratosphere and troposphere, the air is thick enough to sustain life and weather. The mesosphere is neither one nor the other, too thin for planes, too thick for spacecraft. It is a liminal zone, an in-between, a realm that resists human presence. That is why it is sometimes called the ignorosphere, a name half in jest, reflecting how little we once knew about it compared to other layers. But ignorance does not mean insignificance. Its cold heart, its meteors, its noctilucent clouds, its tidal winds, all these make it vital to the balance of the atmosphere. Few people will ever touch the mesosphere directly, yet humanity has already left its mark there. Rockets, missiles, and spacecraft that pass through it leave trails of exhaust and water vapor, which can seed noctilucent clouds. Fragments of satellites burning upon re-entry blaze through its thin air, streaking as fireballs. Even pollution from below can reach upward indirectly, altering its chemistry. The mesosphere may seem remote, but it too is linked to the web of human activity, responding to the subtle changes we imprint on the atmosphere. There is something almost poetic about the mesosphere's role as a shield and stage. It is where the heavens meet the earth, where cosmic dust becomes a shower of light, where storms below send up luminous tendrils, where the boundary of our sky glows with ghostly clouds. It is quiet and hostile, yet beautiful and vital. It is invisible by day, yet spectacular by night. To think of it is to think of transience, of things that flash and vanish, of the fragility of protection, of the hidden layers that keep life safe without our noticing. If you could stand somehow in the mesosphere, protected from its cold and thinness, you would see the world in a new way. Below, the Earth's surface would be curved, vast, and glowing with sunlight or city lights. The troposphere's clouds would look like scattered cotton, storms like swirling white wheels. Above, the sky would darken toward black, and stars would appear even in daylight. Around you, faint veils of noctilucent clouds might shimmer, or a meteor might blaze past, lighting the air. It would feel like standing at the threshold of space, a place where Earth and universe blend. Yet it would also feel lonely, for life does not dwell here. The mesosphere is not a home, it is a passage, a shield, a theater. To tell the story of the mesosphere is to tell the story of connection, between the planet and space, between storms and stars, between what is fragile and what is powerful. It is a reminder that the sky is not empty but layered, each stratum with its own character and role. The troposphere gives us weather and rain. The stratosphere shields us with ozone. The mesosphere protects us from meteors and gifts us with light. The thermosphere and exosphere extend further, but the mesosphere is the middle, the heart, the zone of in-between. It is easy to forget it exists, easy to think only of clouds below or satellites above. But to forget it would be to forget the shield that turns cosmic debris into beauty, the cold layer that ties the atmosphere together, the stage where lightning and stars converse. And so, when you see a meteor blaze in the night, when you glimpse a silver glow of noctilucent clouds in summer twilight, when you hear of sprites leaping above storms, remember that you are seeing the mesosphere. Remember that it is part of the atmosphere that holds you, even if you never feel its wind or breathe its air. Remember that it is not emptiness but presence, not silence but a quiet hum of processes that matter. The mesosphere is not just the middle layer of the sky, it is a reminder that even in between, there is wonder, even in the coldest heights, there is fire, and even in the most remote realms, there is a story of life and earth intertwined. Above the mesosphere's icy silence, beyond the silver shimmer of noctilucent clouds and the burning trails of meteors, begins a realm so vast, so alien, and so unlike anything familiar on Earth that it feels almost like stepping onto another planet. This is the thermosphere, a layer not of calm weather or quiet shields but of fire and light, of extremes that defy ordinary imagination. If the troposphere is the world of storms and rain, if the stratosphere is the shield of ozone, if the mesosphere is the burning gate where meteors fall, then the thermosphere is the realm where Earth's atmosphere begins to glow, where the boundary with space is drawn not by lines on a map but by the dance of particles and light. It is the place where the sky itself becomes alive with auroras, where the air, though impossibly thin, is heated to searing temperatures by the energy of the sun, and where human machines, satellites, and stations circle the planet like tireless companions. To know the thermosphere is to gaze into the borderland between Earth and the cosmos, a place both protective and hostile, both luminous and empty. To reach it, you must climb beyond the mesosphere's cold to about 90 kilometers above the surface. Here begins the lower edge of the thermosphere, though its boundary is not sharp but gradual, a fading of one set of conditions into another. As you ascend higher, to altitudes of 200 or 300 kilometers, you are deep within it, and it continues upward to 500, 700, even 1,000 kilometers, depending on how you measure. Beyond that lies the exosphere, where atoms drift into space. But within this expanse, the thermosphere stretches vast and strange, a region that is still part of the atmosphere yet already feels like space. It is here, in this lofty height, that the familiar rules of air no longer apply, and the language of plasma, ions, and radiation begins to take over. The first thing you would notice in this realm, if somehow you could exist there without protection, is the heat. Not the heat of a summer day, not even the heat of a desert, but temperatures that climb to more than 1,500 degrees Celsius, sometimes even higher. Yet this heat is deceptive, for the air is so thin that it contains almost no molecules to carry warmth to your skin. You would not feel the temperature as we understand it, you would freeze rather than burn, for there are not enough particles to transfer their energy. Temperature here is not sensation but measure, a way of describing the speed at which rarefied atoms race, energized by the sun's ultraviolet and X-ray radiation. They move at furious speeds, but they are too few to warm you. This paradox of extreme heat and simultaneous cold is the signature of the thermosphere, a place where our human sense of touch becomes useless. It is also a place where the atmosphere becomes ionized. The radiation from the sun is so powerful here that it strips electrons from atoms, creating a mixture of charged particles, ions and free electrons, that can conduct electricity and respond to magnetic fields. This region is known as the ionosphere, though it is not a separate layer but part of the thermosphere itself, a functional realm embedded within it. The ionosphere is crucial to life below, though invisible to ordinary eyes. It reflects radio waves, allowing signals to bounce over horizons, making long-distance communication possible long before satellites were ever built. It bends and scatters transmissions, sometimes aiding them, sometimes disrupting them. At night, when the sun's radiation fades, parts of the ionosphere weaken, and signals change. It is a living, shifting mirror, a veil of plasma that humans have unknowingly relied upon for more than a century of communication. And within this ionized world, beauty erupts. High above the poles, when charged particles from the sun stream into Earth's magnetic field, they are guided downward, spiraling along invisible lines toward the thermosphere. There, they collide with atoms of oxygen and nitrogen, exciting them, causing them to release photons of light. The sky glows in curtains and arcs, in shifting veils of green, red, purple. These are the auroras, the northern and southern lights, dancing in the thermosphere's heights. To stand beneath them is to witness the universe writing upon the sky, to see the invisible forces of space translated into color. They shimmer and ripple, sometimes gentle, sometimes fierce, sometimes spreading across the entire horizon. Their forms are shaped by Earth's magnetic field, their colors by the atoms they strike. Oxygen glows green and red, nitrogen glows blue and violet. The auroras are art painted by the marriage of solar wind and thermospheric air, a reminder that Earth is not an isolated world but one connected to the sun in constant dialogue. Auroras are not the only lights of the thermosphere. There are also faint air glows, persistent emissions of light caused by chemical reactions in the upper atmosphere. They are too dim to see with the naked eye, except on the darkest nights, but instruments detect them always. Airglow wraps Earth in a constant faint radiance, a reminder that even in darkness, the atmosphere is alive with energy. To orbit Earth is to see this glow as a thin band, green or red, encircling the planet, a quiet luminescence of the thermosphere. If you were to look around from within the thermosphere, the view would be astonishing. Below, the Earth would spread vast and curved, with oceans and continents bathed in sunlight, clouds swirling in familiar patterns far beneath. Above, the blackness of space would begin, dotted with stars visible even at noon, the sun a blazing disk unfiltered by thick air. Around you, satellites would pass silently, their paths curved by orbital mechanics, not by winds. This is the realm where the International Space Station circles Earth, where astronauts float in microgravity but are still within the atmosphere's grasp, for even here, tenuous particles drag on orbits, slowing satellites over time. To live aboard the station is to live within the thermosphere, protected by walls and suits, gazing out at both Earth and space, dwelling in the boundary between them. The thermosphere is restless, not with weather as we know it, but with space weather, the moods of the sun translated into storms of charged particles and currents. When the sun erupts with flares or coronal mass ejections, torrents of plasma race toward Earth. When they strike the magnetosphere and thermosphere, they trigger geomagnetic storms, surges of energy that intensify auroras but also disrupt communications, knock out power grids, and threaten satellites. The thermosphere swells with energy, expanding outward, increasing drag on spacecraft. What happens 90 to 1,000 kilometers above can ripple down into the lives of billions, as systems falter, as power lines hum, as the fragile web of technology feels the pulse of the sun. To study the thermosphere is to study the vulnerability of our modern world, for it is the gateway through which space weather touches us. Though remote and alien, the thermosphere is not empty of human activity. It is the highway for satellites, the home of stations, the path of re-entry for returning spacecraft. When a capsule descends from orbit, it slams into the thermosphere at tremendous speed, and the air, though thin, compresses and heats, blazing in fire around the craft. Re-entry is a dance with the thermosphere, a careful balance of speed and heat, of shielding and control. Too shallow an angle and the craft skips back into space, too steep and it burns. Astronauts returning to Earth trust their lives to the invisible resistance of this layer, to its ability to slow them with fire until parachutes can take over. Even meteors that survive the mesosphere and reach the ground must pass through the thermosphere first, glowing and fragmenting. It is both gateway and guardian, a layer every traveler between Earth and space must confront. The chemistry of the thermosphere is unique, dominated by atomic oxygen at lower altitudes and lighter gases higher up. Here, the separation of gases begins. The homogeneity of the lower atmosphere gives way to stratification. Nitrogen and oxygen linger at lower levels, while helium and hydrogen drift higher, on the edge of the exosphere. The air is so rarefied that collisions between molecules are infrequent, and the rules of fluid dynamics begin to dissolve into the physics of individual particles. It is a realm where atmosphere becomes space in slow transition, where definitions blur. Scientists call it part of Earth's atmosphere, yet it behaves as much like plasma as like air. Winds exist here too, not breezes you could feel but vast motions of charged particles, guided by the magnetic field, driven by the tides of lower layers and the bursts of solar energy. These winds can reach hundreds of kilometers per hour, unseen but measurable, shaping the ionosphere, altering the flow of currents. The thermosphere is not still, it breathes with the rhythm of the sun, swelling by day, shrinking by night, expanding during solar storms, contracting in quiet times. It is alive in cycles and pulses, responding to the cosmos in ways the lower atmosphere never could. And though life does not exist here naturally, human presence continues to grow. The International Space Station is not alone. Countless satellites orbit through the thermosphere, circling in paths that serve communication, navigation, weather observation, military surveillance. They are the silent fleet of the modern world, dependent on the conditions of this layer. Engineers calculate drag, radiation exposure, orbital decay, all shaped by the thermosphere's moods. Without it, satellites would orbit longer, but without its protective filtering, radiation from space would reach Earth more harshly. The thermosphere absorbs the most energetic solar radiation, X-rays and gamma rays, shielding the surface from their destructive force. It is both a hindrance and a guardian, a space where human technology must struggle but also a shield that makes life below possible. The thermosphere is also the birthplace of wonder for those who leave Earth. Astronauts who orbit within it see the thinness of the atmosphere as never before. They see the auroral ovals circling the poles, vast and shimmering. They see the air glow ringing the Earth like a halo. They see meteors from above, streaking downward toward the mesosphere. To live even temporarily in the thermosphere is to live in awe, to see the planet as a fragile sphere wrapped in delicate layers, suspended in the dark. Many return with a changed sense of life, of home, of fragility. The thermosphere does not just shield, it reveals perspective. To tell the story of the thermosphere is to tell the story of thresholds. It is the threshold between atmosphere and space, between air and plasma, between Earth's weather and the sun's storms. It is the place where particles from the cosmos meet particles from Earth, where energies exchange in light and fire. It is a place humans cannot inhabit yet cannot avoid, for every rocket, every satellite, every signal that touches the sky must pass through it. It is invisible by day, spectacular by night, a realm that makes the aurora dance, that shapes the reach of radio, that decides the fate of spacecraft. It is at once hostile and protective, empty and alive, thin and vast. If you think of the atmosphere as a symphony, the thermosphere is its highest notes, shimmering and bright, carrying the echoes of the sun. If you think of it as a wall, the thermosphere is its rampart facing space, glowing in the fire of auroras, breaking the fury of solar storms. And if you think of it as a journey, the thermosphere is the final gate, the passage every traveler to the stars must walk. It is not merely a layer of air, it is a place where Earth itself reaches upward, answering the cosmos with light. Beyond the fire and shimmer of the thermosphere, higher than the orbits of most satellites, farther than the aurora's dancing arcs and the glow of air itself, lies a realm that is almost not Earth anymore. It is the exosphere, the final breath of the atmosphere, a place where the sky loosens its grasp on matter and lets atoms drift toward the deep silence of space. To cross into it is to enter a frontier without fences, where the word air becomes almost meaningless, and where Earth's identity as a planet with atmosphere blurs into the vastness beyond. The exosphere is not a place of weather, nor storms, nor clouds, but of transition, of thresholds, of escape. It is the edge where Earth whispers into the cosmos. From the surface, you will never see it. Even from an airplane, even from a balloon, even from the high glides of supersonic jets, you will not glimpse it. It begins where the thermosphere thins into near-nothingness, somewhere around 600 kilometers above the surface, though its lower edge swells and contracts depending on the sun's moods. Its upper limit is not sharp, stretching out thousands of kilometers, to 10,000 perhaps, before atoms are no longer bound by Earth at all. This layer is so tenuous that to call it an atmosphere feels like poetry more than science. The atoms are so far apart that they may travel hundreds of kilometers without colliding. In truth, it is more like the outskirts of an invisible ocean, where the water thins into mist and the mist fades into emptiness. Here, hydrogen drifts free. Helium too. Lighter than oxygen or nitrogen, these atoms rise higher and higher, forming the main fabric of the exosphere. Each one is like a wanderer, set loose, barely tethered to Earth's gravity. Some are captured for a while, orbiting in slow arcs before descending again, while others slip away entirely, escaping into interplanetary space. This is the slow breathing of Earth into the void, the loss of atmosphere molecule by molecule, a process so gentle that it takes eons, but relentless all the same. Every second, Earth is exhaling, feeding the space between planets with traces of itself. Imagine being here, though no human has ever stood in the exosphere. If you could somehow float at these heights, protected from the lethal radiation and the vacuum, you would see the world below in full glory, a blue marble wrapped in faint veils of cloud, the continents glowing in sunlit colors, the oceans gleaming in vast swaths of sapphire. But above you, blackness. Not the deep dark blue of the sky seen from mountaintops or even the ink black of the thermosphere seen from orbit, but true cosmic black, studded with stars sharp and unblinking. The sun would blaze with unfiltered fury, casting stark shadows and dazzling brightness. You would feel as though you were already in space, because in every practical sense, you are. The exosphere is space's doorstep, a region that belongs to both Earth and the cosmos, and to neither fully. Yet though it is so thin, the exosphere plays its role. It shields Earth in its own faint way, serving as the arena where Earth's magnetic field and solar winds wrestle. Charged particles stream from the sun constantly, a gale of plasma called the solar wind, and the exosphere is where they first encounter Earth's resistance. The magnetic field stretches outward here, creating a protective bubble called the magnetosphere. This bubble is not the exosphere itself, but the two overlap, interlacing, with exospheric atoms mingling with the charged currents of space weather. It is here that Earth defines its place against the sun's relentless wind. Without this vast, invisible shield, the solar wind would have long ago stripped the atmosphere bare, as it has done to other worlds like Mars. The exosphere may look fragile, but it is part of the architecture of survival. There are no clouds here, no storms of rain, snow, or thunder. The weather of the exosphere is cosmic, not terrestrial. Its storms are geomagnetic, invisible battles of electrons and protons, surges of plasma, auroral ovals expanding and contracting far below. It is a realm without sound, for sound requires air, and here the atoms are too few to carry vibrations. If you shouted, nothing would move, nothing would answer. The silence is absolute. Only light and particles, only the thin haze of hydrogen shining faintly in ultraviolet when struck by the sun, only the ghostly presence of a planetary halo. Astronomers have called this halo the geocorona, a cloud of hydrogen extending far beyond what human senses can detect, surrounding Earth like an invisible aura. Photographs from space show it as a pale blue glow when captured in the right wavelength, stretching far beyond the Moon's orbit. That glow is part of the exosphere, Earth's faint breath reaching into space. Spacecraft pass through this region silently, often on their way farther outward. Satellites in high orbits, like those of navigation systems or weather monitoring, skim the exosphere. They are no longer slowed by drag, as they would be lower down, but they are not immune to its touch. Even a few atoms brushing against a satellite at orbital speeds can matter over years, altering trajectories, shortening lifetimes. Engineers must account for the exosphere, invisible though it is, when planning the paths of machines. And every craft leaving Earth, every probe launched to the Moon, Mars, or beyond, must cross this invisible veil. Rockets burn through the dense lower layers in minutes, but the exosphere is passed without drama, with no fiery trails, no blazing re-entry. To leave Earth through the exosphere is to slip quietly into the stars. The exosphere is not static. It breathes with the sun. During solar storms, when flares and coronal ejections blast torrents of energy outward, the exosphere swells, expanding farther into space, like a balloon pushed by invisible hands. Hydrogen atoms stream farther, the geocorona grows. During quiet times, it contracts, holding close. This expansion and contraction is not something we feel on the ground, but satellites and spacecraft know it well. Even the faintest shift in density can matter at orbital speeds, where a molecule of hydrogen becomes a whispering drag, a slowing, a pull toward Earth. To consider the exosphere is to think about impermanence. Earth has not always had the same atmosphere, and it will not always keep it. Slowly, invisibly, particles drift away, lost forever. Over billions of years, these tiny losses accumulate. Hydrogen, the lightest and most abundant, escapes most easily, and with it goes water, in slow trickles. Mars once had a thicker atmosphere, rivers and seas, but lacking a strong magnetic field, it lost them to the solar wind, its exosphere powerless to hold them. Earth endures, protected by magnetism, yet still it loses. The exosphere is the leak in the jar, the place where air becomes unbound. It is a reminder that nothing, not even the air we breathe, is eternal. There is also mystery here. Measuring the exosphere is difficult, for how do you measure something so close to nothing? Instruments on satellites count particles, track their motions, estimate densities, but the boundaries remain fuzzy. Where does atmosphere end and space begin? Some define it at the Kármán line, a neat 100 kilometers above Earth, but that is only a convention. In truth, atmosphere thins gradually, with no sharp edge, until in the exosphere it simply blends into the interplanetary medium. If you follow an atom long enough, you cannot say when it ceased to belong to Earth and began to belong to space. The border is philosophical as much as scientific. If one could give the exosphere a voice, it would speak softly, almost inaudibly, whispering rather than roaring. It would speak of patience, of time measured not in centuries but in ages, of loss so gradual it becomes almost eternal. It would speak of connection, of Earth not as an isolated ball but as a planet with tendrils stretching outward, mingling with the sun's winds, touching the edge of the Moon's orbit with its halo. It would speak of fragility, of the delicate balance that keeps our atmosphere intact, of the magnetosphere's role in fending off annihilation, of how thin the veil of safety truly is. For astronauts who travel through it, the exosphere is both invisible and overwhelming. They pass through in capsules and stations, never feeling it directly, yet seeing its consequence. The sharpness of stars, the blackness of space, the thin arc of Earth's limb, all are shaped by this thinning. The airglow, visible as a faint band of color encircling the planet, is the last visible expression of the exosphere's atoms. Beyond that, there is nothing but cosmic dark. Astronauts often describe the experience as transformative, the so-called overview effect, a sudden awareness of Earth as fragile, finite, wrapped in a thin skin of air, set against the infinite. Though they do not linger in the exosphere, they pass through it, and it becomes part of their vision of home. Science sees the exosphere as data, densities, compositions, escape velocities, radiation balances. But there is poetry in it too. To think of Earth as surrounded by a halo of hydrogen, glowing faintly in ultraviolet, extending beyond the moon, is to see our world not just as a rock with an atmosphere but as a living presence in space, breathing out, luminous in unseen light. To know that every spacecraft passes through it, silently, is to think of it as a gate, a border crossed in silence but carrying profound meaning. To understand that it is where our air is lost, atom by atom, is to glimpse the slow erosion of time. And to realize that it is the place where Earth meets the solar wind, where the planet defends itself against the star that gave it life, is to see it as a battlefield, delicate yet essential. The exosphere is, in the end, a paradox. It is the atmosphere, but it is also space. It is both something and almost nothing. It is invisible, yet it extends farther than we imagine. It is fragile, yet it helps protect a planet. It is quiet, but it shapes communication, navigation, and exploration. It is the last layer of sky, yet it is the first touch of the cosmos. And perhaps that is its truest essence, it is the threshold, the liminal zone, the place between worlds. When you look up at the stars at night, you are not just seeing them through air. You are seeing them through the thinning skin of the exosphere, through the last breath of Earth's atmosphere before it gives way to infinity. You are looking through a veil that stretches farther than the moon, a veil you cannot see but that exists all the same. And every photon of starlight you see has passed through that veil, just as every spacecraft we launch must. The exosphere does not announce itself, does not roar with thunder or glow like the aurora, but it is there, quietly framing our view of the universe. It is the silence after the song of the lower sky, the lingering note that fades into space. The atmosphere has always seemed endless, a boundless ocean of air stretching above, so immense that human beings once believed nothing they did could ever disturb it. For most of history, it was taken for granted as infinite, untouchable, the sky itself immune to the actions of those who walked upon the ground. Yet the truth is different. The atmosphere is vast, but it is also fragile, a thin veil clinging to Earth, no thicker in proportion than the skin of an apple. What threatens it is not only the violence of nature, volcanoes, impacts, solar storms, but also the relentless activities of the very species it sustains. It is being shaped, bent, and wounded by choices made on the surface, sometimes by accident, sometimes by carelessness, sometimes by greed. The threats are many, and each one, in its own way, carries the potential to unmake the delicate balance that allows life to flourish. One of the greatest threats is the slow thickening of the atmosphere with gases that trap heat. Carbon dioxide, methane, nitrous oxide, once natural elements of a balanced cycle, have been released in quantities far beyond what the Earth can absorb. For millions of years, forests, oceans, and soils kept carbon in check, exchanging it with the air in rhythms older than humanity. But in a mere 2 centuries, humans have dug up carbon locked in coal and oil and gas, and sent it rushing skyward in burning clouds. The atmosphere, once a partner in equilibrium, is now burdened with excess. These gases are invisible, odorless, seemingly harmless as they rise from chimneys, cars, and fields. Yet they are powerful, weaving an extra blanket around the Earth, trapping heat that should escape to space. The atmosphere warms, the climate shifts, storms grow fiercer, droughts longer, seas higher. It is not the presence of these gases alone that threatens, but their imbalance. The atmosphere thrives on balance, it suffers under excess. Another threat hides higher up, where the ozone layer resides. Ozone is only a trace gas, but it performs a mighty task, absorbing the sun's ultraviolet radiation, preventing it from searing life below. For most of history, it was a shield unnoticed. Then human industry created compounds, chlorofluorocarbons, or CFCs, stable, versatile, harmless to breathe, used in refrigerators, spray cans, and solvents. They seemed miraculous inventions. Yet once released, they rose quietly, invisibly, into the stratosphere, where sunlight broke them apart. From their fragments came chlorine atoms, ruthless and persistent, each capable of destroying thousands of ozone molecules. A hole opened in the sky above Antarctica, a wound in Earth's shield. Suddenly, what was unseen became urgent. The atmosphere, once thought invulnerable, had been injured by chemicals no one had expected to be dangerous. Though the world came together to ban CFCs, the lesson remained: what we do below echoes above, often in ways we cannot foresee. Pollution in its many forms also gnaws at the atmosphere. Smoke and soot, nitrogen oxides, and sulfur dioxide rise from factories and engines, turning clear air into haze, sunlight into smog. In cities, the air grows thick, acrid, burning throats and lungs. These pollutants mix with moisture to form acid rain, which falls upon forests, rivers, and stone, corroding ecosystems and monuments alike. Though the atmosphere disperses much of it, the cumulative weight is heavy. Air pollution is not merely a nuisance, it is a constant erosion of the life-giving clarity of air, a slow poisoning that shortens lives and sickens landscapes. Where once the wind was cleansing, it now carries contamination. Deforestation and land misuse also threaten the atmosphere, though less obviously. Trees are partners in the great breathing of Earth, taking in carbon dioxide and exhaling oxygen. Forests act as vast lungs, filtering the air, stabilizing climate, shaping rainfall. Yet chainsaws and fires strip them away, turning living green into barren fields. With each acre lost, the atmosphere loses a regulator, and more carbon lingers above. The destruction is not confined to forests alone. Soils, when overworked and eroded, release carbon they once stored. Wetlands, drained and filled, lose their power to filter and absorb. The land itself, misused, becomes a source of atmospheric burden rather than a partner in its balance. There is also the threat of aerosols, tiny particles suspended in air. Some are natural: dust, sea salt, volcanic ash. But many are human-made: industrial smoke, agricultural residue, microplastics. They scatter sunlight, cool or warm the air, alter rainfall patterns. Some reflect heat, others absorb it. They seed clouds, changing when and where rain falls. Too many aerosols choke the sky, dimming the sun, making horizons hazy. They do not last as long as greenhouse gases, but in their abundance they disrupt the delicate dance of energy between Earth and space. They may seem trivial, invisible to most eyes, yet their cumulative effect is profound, a constant interference in the workings of the atmosphere. High above, in the thin reaches where the atmosphere kisses space, lies another danger: the slow but steady accumulation of space debris. Satellites and rockets, launched in pursuit of communication, science, and exploration, leave behind fragments, bolts, shards, discarded stages. These orbiting remnants threaten not the chemistry of the atmosphere but its role as a shield. For when debris collides, it creates more fragments, a cascading hazard. If left unchecked, it could litter the upper reaches of air with a cloud of shrapnel, making launches dangerous, limiting our ability to monitor and understand the very atmosphere we endanger. The threat is subtle but real. The sky itself, once infinite, is becoming crowded with the relics of our ambition. Even natural events threaten the atmosphere, though they are beyond human control. Volcanoes erupt, spewing ash and sulfur high into the stratosphere, dimming sunlight, cooling Earth for months or years. Large impacts from space, though rare, could fill the air with dust and smoke, plunging the planet into darkness, collapsing food chains. Solar storms send waves of particles that batter the upper atmosphere, disrupting satellites and communications, stripping away molecules. Though these events are infrequent, they remind us that the atmosphere is not guaranteed, that it lives under constant stress from forces both below and beyond. Yet among all threats, perhaps the greatest is the human tendency to forget. The atmosphere is invisible, intangible, always present, and so it fades into the background of thought. People notice dirty water, barren fields, dead forests, but air is taken for granted until it chokes, until it burns, until it is gone. Neglect is its own danger, for it allows harm to accumulate unnoticed, until it becomes irreversible. The atmosphere does not speak loudly, it whispers in shifting winds, in warming nights, in thinning clouds. To hear it requires attentiveness. To ignore it is to allow the slow unraveling of the world's fabric. The threats to the atmosphere are not isolated, they intertwine. Greenhouse gases warm the planet, which alters rainfall, which dries forests, which release more carbon when they burn. Pollutants create haze that cools one region while warming another, shifting monsoons, straining agriculture. Ozone loss exposes life to radiation, weakening ecosystems already stressed by heat and drought. The atmosphere is a system, and every threat ripples through it, magnified by its connections. What seems like a small harm in one place becomes a larger wound everywhere. In this way, the atmosphere is both victim and messenger. Its chemistry changes with our emissions. Its patterns shift with our deforestation. Its clarity dims with our smoke. It does not lie. It records, faithfully, every action, every mistake. Ice cores preserve ancient atmospheres, showing us what was and what is. Current measurements track the rising curve of carbon, the thinning of ozone, the persistence of pollutants. To study the atmosphere is to read the diary of Earth, and that diary reveals the threats plainly, without exaggeration. Yet even in the face of these dangers, the atmosphere remains resilient. When CFCs were banned, ozone began to heal. When sulfur emissions were reduced, acid rain declined. When forests are protected, carbon is drawn down again. The threats are serious, but the atmosphere responds when given care. Its fragility is matched by its ability to recover, if the harm is stopped, if balance is restored. The story of its threats is also a story of choices, whether humanity continues to wound, or begins to heal. The atmosphere is threatened not only by what we release but also by what we fail to value. To see it as endless is to treat it as a dump. To see it as essential is to protect it. Its thinness makes it vulnerable, its vastness makes it shared. No border can hold it, no nation can own it. What one people release, another breathes. What one land pollutes, another suffers. The threats to atmosphere are global, and only a global mind can meet them. The air is life's common ground, the one thing every being shares. It is sacred by its very nature. Yet it is threatened, daily, hourly, invisibly, by 1,000 cuts. The smoke of fires, the exhaust of engines, the felling of forests, the chemicals of industry, the neglect of the powerful. These are the true dangers, not because they are inevitable, but because they are chosen. The atmosphere does not threaten itself, it is threatened by what we do and what we fail to undo. To speak of threats is not to speak of doom, but of urgency. For the atmosphere is not gone, it is still here, still sheltering, still nourishing. Its wounds can be healed. Its balance can be restored. But only if its threats are faced directly, acknowledged, and undone. The sky we see each day is a reminder, not of distance, but of intimacy. It is not above us, it is around us, within us. To threaten it is to threaten ourselves. To protect it is to protect everything. So when you step outside and draw breath, know that it is not merely air you inhale. It is the future, fragile and enduring, threatened yet resilient. It carries the memory of forests, the touch of oceans, the warmth of sunlight, the chill of starlight. It carries also the scars of our actions. Whether those scars deepen or fade is the question of our age. The atmosphere is threatened. But it is not lost. And the story of its threats is also the story of whether humanity will choose to be its guardian or its undoer. To preserve the atmosphere is to preserve ourselves, though we rarely think of it that way. The sky above seems so vast, so eternal, so far beyond our grasp, that it is easy to forget it is fragile, easy to imagine it immune to our touch. But in truth it is thin, no thicker in proportion to earth than the skin on a fruit, and within that delicate envelope all life is held, all breath sustained. What happens there is what happens to us. To keep it whole requires not reverence in words alone, but deliberate action, sustained choices, and the will to protect what sustains. Preserving the atmosphere is not a single act, but 1,000, each woven into daily life and global policy alike, each step a thread in the fabric of a future worth living. The first action is to see the atmosphere as shared. Air knows no borders. What is released in one land drifts to another, what is burned in one season settles in another hemisphere. The smoke of fires in distant forests, the exhaust of cars in faraway cities, the chemicals vented from factories across oceans, they all mingle in a single breath we call the sky. To preserve it demands a recognition that the atmosphere belongs to no one and to everyone, that stewardship cannot be confined within lines drawn on maps. International cooperation is not an option but a necessity. Agreements must be made, treaties strengthened, promises kept. Nations must act together as tenants of the same home, for the air unites them whether they wish it or not. To protect the atmosphere also means to transform the engines of our civilization. The great release of carbon dioxide, methane, and nitrous oxide into the air comes from how we make energy, how we grow food, how we travel, how we build. To preserve the balance of gases, the burning of coal, oil, and gas must give way to cleaner sources. Sunlight captured on panels, wind harnessed by turbines, tides and geothermal heat, these are the tools by which the atmosphere may be relieved of its burden. Each kilowatt pulled from wind instead of coal is a gift to the sky. Each building insulated to save energy is a pledge of care. Every choice to walk, to cycle, to ride together rather than alone in engines burning oil, is a small thread in the larger tapestry of preservation. These choices are not merely technical, they are cultural. They require a reimagining of progress, one that no longer sees smoke as a sign of prosperity, but clear air as a measure of success. Agriculture, too, must change, for the atmosphere is altered not only by smokestacks and engines but by fields and herds. Fertilizers release nitrous oxide, livestock produce methane, deforestation for farmland strips the earth of carbon sinks. To preserve the atmosphere requires more sustainable farming, practices that use nutrients wisely, that recycle rather than waste, that capture carbon in soil rather than release it. Forests must be spared and restored, for each tree draws down carbon, each root holds soil, each canopy shapes rain. Diets, too, play their part. Less dependence on meat and more on plants reduces pressure on land and lowers emissions. To choose a meal is to choose an impact, to choose wisely is to give the atmosphere a chance to heal. Industry has its role, for factories and production release chemicals and particulates that scar the air. Technologies exist to capture emissions, to filter smoke, to recycle materials rather than incinerate them. Cleaner processes, closed loops, reduced waste, these are not dreams but present possibilities, waiting for will and investment. Preserving the atmosphere is not only about avoiding harm but about inventing better ways, systems that align profit with protection, progress with preservation. Innovation must be guided not by what is cheapest in the moment, but by what sustains in the long span. There is also the duty to protect the ozone layer, that fragile band in the stratosphere that shields life from ultraviolet radiation. The world once proved it could act together, banning the CFCs that threatened it. But vigilance is needed still, for other chemicals, like HCFCs and halons, linger, and replacements must be chosen with care. To preserve the atmosphere is to learn from past victories. To recognize that what seemed impossible, a global ban on widely used substances, was done when survival demanded it. That spirit must continue, not as exception but as norm. Transportation, the bloodstream of modern civilization, is both a marvel and a burden. Billions of vehicles crisscross roads, skies, and seas, each one breathing exhaust into the air. To preserve the atmosphere, the engines of movement must be remade. Electric vehicles, powered by clean energy, must replace the burning of oil. Trains and buses, efficient and shared, must be chosen over fleets of solitary cars. Aviation, one of the most stubborn sources, must invest in cleaner fuels, more efficient designs, and alternatives where possible. Even ships that carry the commerce of the world must shift from burning heavy oils to technologies that honor the air. The freedom of movement need not mean the poisoning of sky, but it requires courage to change the patterns we have built. Another action lies in cities, for they are the hearths of human life and also the chimneys of emissions. Urban design can preserve the atmosphere by shaping how people live, compact neighborhoods that encourage walking, green spaces that absorb carbon and filter air, buildings that breathe efficiency rather than waste. Rooftop gardens, tree-lined avenues, walls covered in living plants, all these not only cool cities but cleanse their air. When cities embrace clean transport, renewable energy, and sustainable design, they become allies of the atmosphere rather than enemies. Preserving the atmosphere also means reducing pollution at its smallest scale, the particulates and toxins that harm lungs and dim skies. Laws that regulate emissions, technologies that scrub smokestacks, systems that monitor and report air quality, these are tools of preservation. But beyond tools is the spirit of vigilance. Air cannot be seen until it is dirty, by then, harm is already done. Monitoring, accountability, and transparency are essential, for only when air is measured can it be managed, and only when it is valued can it be preserved. Forests and oceans must be treated as partners, for they are not separate from atmosphere but extensions of it. Forests absorb carbon, oceans exchange gases, wetlands filter air and water alike. To cut a forest is to wound the sky, to poison an ocean is to foul the breath of the planet. Reforestation, conservation, restoration, these are not luxuries but necessities. Every sapling planted, every wetland protected, every reef nurtured back to life, is an act of preservation that ripples upward into the atmosphere. The balance of gases cannot be maintained by air alone, it is tied to the living world, and preserving one preserves the other. Education is itself a form of preservation. To teach the young that the sky is fragile, that each choice affects it, that it is not endless but finite, is to raise guardians rather than exploiters. To spread awareness is to give people the power to act, for ignorance is often the root of harm. When people understand that the atmosphere is not an abstract concept but the breath in their lungs, the rain in their fields, the climate of their homes, they will defend it. Knowledge is the seed of responsibility, and responsibility is the root of action. Yet preservation is not only a matter of policy or technology or education, it is also a matter of culture. A culture that glorifies consumption, that equates growth with waste, that celebrates smoke as progress, will always threaten the atmosphere. A culture that values simplicity, that honors balance, that sees restraint as wisdom, will preserve it. Stories, art, traditions, these shape how societies view the sky. To cultivate a culture of stewardship is to embed preservation into daily life, making it not an obligation but a way of being. There is also the action of humility, recognizing that the atmosphere is not ours to dominate but ours to share. We are one species among millions, each dependent on the same air. To poison it for short-term gain is to betray not only future generations but all creatures that breathe. Preserving the atmosphere requires compassion that extends beyond humanity. A recognition that birds, beasts, forests, and seas are fellow passengers under the same dome. Ethics, as much as science, must guide preservation. Innovation must continue, for the challenges are immense and the old ways inadequate. Technologies to capture carbon directly from air, to store it safely in stone or sea, are being born. These may be tools to buy time, to undo some of the damage already done. But they cannot replace restraint, they can only complement it. The greatest preservation comes not from cleaning after harm, but from preventing harm in the first place. Prevention is wiser than cure, foresight better than desperation. And always, the atmosphere demands vigilance against complacency. Victories are fragile. The healing ozone is still vulnerable. Reductions in emissions can be undone by inaction. The path of preservation is never complete, for the atmosphere is always in motion, always in flux. To preserve it requires constant attention, renewal of commitment, adaptation as new challenges emerge. Preserving the atmosphere is, at its heart, an act of love. Love for the unseen, the intangible, the air that gives us voice and breath, that paints the sky and carries the rain. It is love expressed in discipline, in sacrifice, in vision. It is choosing the long life of earth over the short hunger of profit. It is listening to the whispers of wind and the warnings of storms and answering not with despair but with resolve. Imagine a world where the actions have been taken, cities green and vibrant, skies clear, storms less violent, forests restored, oceans breathing freely. Imagine a world where energy comes from sun and wind, where vehicles glide without smoke, where industry builds without waste. The atmosphere in such a world would not only be preserved, it would be celebrated, honored, embraced. That world is not fantasy. It is possibility. But it depends on choices made now, actions taken here, resolve embraced by all. The actions that preserve the atmosphere are not distant or abstract, they are immediate and tangible. Plant a tree. Walk instead of drive. Conserve energy. Eat wisely. Support leaders who act with foresight. Demand accountability. Teach children to see the sky not as empty but as everything. Each small act matters, for the atmosphere gathers them all, weaving them into its breath. No one action will save it, but together they will. The atmosphere does not ask for miracles. It asks for respect, for balance, for care. It asks that we remember it is not infinite, that it is not ours alone, that it is as alive as the world it surrounds. To preserve it is not to burden ourselves but to free ourselves, for in protecting the air, we protect life, we protect beauty, we protect the only home we have. And so, the path is clear: act with wisdom, act with courage, act with love. The atmosphere will endure if we let it, will heal if we help it, will sustain if we respect it. It is thin, it is fragile, it is threatened, but it is also resilient, responsive, forgiving. The actions are known. The question is only whether we will take them. And the answer to that question will be written not in speeches or promises, but in the sky itself, in the clarity of air, in the calm of climate, in the breath of generations yet unborn. The atmosphere is more than a blanket of gases draped around the earth. It is the breath of the planet, the pulse of its seasons, the unseen thread that ties oceans, forests, deserts, and cities into one great web of existence. It shields us from the harshness of space, yet also carries the warmth of the sun and the coolness of the night. It whispers through the rustle of leaves, roars through the power of storms, and glows with color when touched by the setting sun. Within it lies both constancy and fragility, stable enough to cradle life for billions of years, yet delicate enough that small changes can shift climates and alter the fate of civilizations. To look upward is to be reminded that we live not under the sky but within it, immersed in this invisible sea that nourishes and protects us. The atmosphere is not just part of the earth, it is part of us, and in preserving it, we preserve the story of life itself.